Imagine a small device. It sits quietly on your ceiling. Most days you barely notice it. Yet this unassuming gadget is a lifesaver. It is your smoke detector, a silent sentinel always on duty. It watches for the first hint of danger. Its piercing alarm can mean the difference between safety and tragedy. But where did this vital protector come from? Its origins are quite surprising. It was not born in a typical safety workshop. The story of the smoke detector is fascinating. It begins in a place you might least expect. It starts in the world of nuclear physics. Deep within laboratories, scientists were exploring atoms. They were unlocking the secrets of radioactivity. This was cutting-edge research. It was complex and often dangerous. Their work focused on understanding fundamental forces. They were not thinking about house fires, yet their discoveries laid the groundwork. The journey from a nuclear lab to your living room is remarkable, and it all started with the atom. Our story takes us back to the 1930s and 40s. This was a pivotal time for physics. Scientists were delving into the mysterious world of radioactivity. They needed tools to detect and measure this invisible force. One such crucial instrument was the ionization chamber. This device was essential for their experiments. It allowed them to observe the effects of radiation. Without it, progress would have been much slower. These chambers were the unsung heroes of early nuclear labs. An ionization chamber is a relatively simple concept, yet it is incredibly effective. It typically consists of a gas-filled container. Inside, there are two electrodes with a voltage applied across them. When radiation passes through the gas, it creates ions. These ions are charged particles. The electric field between the electrodes causes these ions to move. This movement creates a small electrical current. This current could then be measured. It indicated the presence and intensity of radiation. These chambers were not designed to detect smoke. Their purpose was purely scientific. They helped researchers understand radioactive decay. They were used in experiments that led to great discoveries. The magic behind the ionization chamber lies in alpha particles. These are a type of radiation. They are emitted by some radioactive materials. Alpha particles are relatively large. They consist of 2 protons and 2 neutrons. Essentially, they are helium nuclei. Despite their origin in nuclear processes, they have a useful property. They are very good at ionizing air molecules. This means they can knock electrons off air molecules. This creates pairs of positively charged ions and negatively charged electrons. Inside an ionization chamber, a small amount of radioactive material emits these alpha particles. This material is carefully chosen and shielded. The alpha particles constantly ionize the air within the chamber. This creates a steady flow of ions. These ions are collected by the electrodes. This generates a small, constant electrical current. This current is the baseline. It tells the device that everything is normal. The air is clear. Now imagine smoke particles entering this chamber. Smoke is made of tiny bits of unburnt material. These particles are much larger than air molecules or ions. When smoke enters the chamber, these particles get in the way. They attach themselves to the ions. This makes the ions heavier and slower. The result is a disruption of the normal ion flow. This drop in current is the signal. The leap from a lab instrument to a home device was significant. It required vision and engineering skill. While the principle was understood by the 1940s, practical smoke detectors were still far off. Ionization chambers were bulky. They were expensive. They were designed for scientific precision, not mass production. Someone needed to see the potential for home safety. Someone needed to adapt the technology to make it small, affordable, and reliable for everyday use. This was the challenge. This crucial adaptation happened primarily in the 1960s. Engineers and inventors began to explore the idea seriously. They recognized the life-saving potential. If a device could warn people about a fire early, lives could be saved. The key was to miniaturize the ionization chamber. They also needed a safe, long-lasting source of alpha particles, and the electronics had to be simple and robust. The goal was a self-contained unit, one that could run on household power or batteries. Swiss physicist Walter Jaeger is often credited with a key invention in this field. In the late 1930s, he tried to create a sensor for poison gas. His device used an ionization chamber. He found that gas particles entering the chamber changed its electrical current. How does that ionization smoke detector on your ceiling work? Let's look inside. The heart of the device is a small ionization chamber with a tiny amount of americium-241. Americium-241 is a man-made substance and a byproduct of nuclear reactors. It emits alpha particles which collide with air molecules, knocking electrons loose. This creates ions and free electrons, generating a small electric current. As long as the air in the chamber is clean, this current flows uninterrupted. The invention of the home smoke detector is a true public health triumph. Its impact on saving lives is undeniable. Before their widespread adoption, house fires were often detected too late, or a fire could start in an unoccupied part of the house. By the time flames were visible, escape routes could be blocked. The smoke detector provided that critical early warning. Studies show a dramatic reduction in fire-related deaths. This reduction correlates with the increased use of smoke detectors. A working smoke detector can cut the risk of dying in a home fire by half. It translates to thousands of lives saved each year. The loud beep of a smoke alarm is designed to wake you. It alerts you before smoke fills your home. This early alert gives you time to react, time to get your family out, time to call emergency services. These crucial moments can make all the difference. While ionization smoke detectors are highly effective for certain types of fires, technology rarely stands still. Scientists and engineers continued to seek improvements. They looked for ways to detect different kinds of smoke. This led to the development of another type of smoke detector. This is the photoelectric smoke detector. It works on a completely different principle. It uses light, not radiation. This offers an alternative and sometimes complementary approach to fire detection. Photoelectric alarms use a chamber with a light source. This light source is aimed away from a light sensor. Think of it like a dark room with a flashlight beam. The beam is not pointing directly at your eyes. In normal, clear air conditions, the light beam travels straight. It does not hit the sensor. The sensor detects no light. The alarm remains silent. This is the standby mode for a photoelectric detector. It is waiting for something to scatter the light. When smoke enters the chamber of a photoelectric detector, the smoke particles act like tiny mirrors. They scatter the light from the light source. Some of this scattered light now hits the light sensor. The evolution of smoke detection did not stop with photoelectric technology. In recent years, we have seen the rise of smart smoke alarms. These devices take fire safety to a new level. They integrate with modern connected home ecosystems. They offer more features and greater convenience. Smart alarms are not just about sounding a local alarm. They can communicate. They can provide more information. They can be controlled remotely. This is a significant step forward. Smart smoke detectors often connect to your home Wi-Fi network. This allows them to send alerts to your smartphone. So, if you are away from home, you can still be notified of a fire. This is incredibly valuable. It means you can call emergency services, even if you are not there. Some smart alarms can also tell you which room the smoke is detected in. This helps you understand the situation better. They might even speak with a human voice. Instead of just beeping, they can say, "Smoke detected in the kitchen." Many smart alarms also include carbon monoxide detection. Carbon monoxide is an invisible, odorless, deadly gas. Combining smoke and CO detection in one unit is a sensible safety measure. The journey of the smoke detector is far from over. From its surprising nuclear origins to today's smart devices, it has constantly evolved. And this evolution continues. Researchers are always looking for new ways to improve fire detection. They aim for earlier warnings, more accurate detection, fewer false alarms, and greater integration with other safety systems. The goal remains the same, to save lives and protect property. But the methods are becoming increasingly sophisticated. Future smoke detectors might use advanced sensor arrays. These could detect a wider range of fire signatures, not just smoke particles, but also specific gases, or changes in temperature and light patterns. Artificial intelligence and machine learning could play a bigger role. AI could analyze sensor data to distinguish between a real fire and nuisance sources, things like burnt toast or steam. This would reduce false alarms, which is a common complaint with current detectors, making them more reliable. Imagine detectors that can pinpoint the exact location of a fire, or even identify the type of material burning. This information could be invaluable to occupants and firefighters. Integration with building management systems could allow for automated responses. Pretty wild that nuclear science is quietly protecting your home, right? If you learned something new, hit like and subscribe. There's so much more to uncover.